Hey there, friend. My name is Christina Rafano from NursingSOS.com, and in this video today, we are going to walk through IV flow rates. My friend, this has been such a huge request to do more dose calc practice problems for you, and especially as we are gearing up for another term in nursing school, it's just so important. I know I've talked about it again and again and again on this channel, but it is so important that you understand dose calc inside and out before you start a new term in nursing school, or really before you take any nursing school exam, because dose calc questions are going to show up all the time on your nursing school exams and on the NCLEX. So they are so important to do. So I am really excited to go through this dose calc series with you here on my channel, because we're gonna do a lot of practice problems together, and I'm gonna go through our 6-step process to make sure that you are geared up and ready to ace your dose calc exam and get every single dose calc problem right. You absolutely can do it. And here's the kicker about nursing school is that you actually do have to get every single dose calc question right on your exam, or you'll get kicked out of the program. Like, that is the standard across nursing schools. You have to pass your dose calc exam in order to stay in the program. And most nursing schools require a 100% to pass. Some nursing schools do a 90% to pass, which, if that's you, like, just be blessed. Like, be so grateful about that because that's not always the case. A lot of nursing schools do require 100% to pass. So this is very important stuff. I want to make sure that you are prepped and ready to go. So let's go through some practice problems, and make sure you subscribe and hit the bell on my channel so you don't miss out on the next videos that I do. I've got a lot of really great dose calc videos coming for you that I'm really excited about. I really want to make sure that you are prepped and ready to go. So let's dive into the practice problems. Now, before we dive into the practice problems, I want to make sure that you know that I just released a brand new dose calc system, including flashcards. So this is a full course that I have for you that walks you through step-by-step how to ace your dose calc exam. It's going to walk you through everything from PO meds to IV calculations to heparin and titrations and pediatric and weight-based calculations, everything that you need to know in order to pass your dose calc exam. And you get these awesome conversion flashcards sent to you in the mail as well. They are so fun. So I will put the link down below in the description for you to check out all the details for the dose calc system. So the first problem we have says this: you'll be giving 500 milligrams of medication B mixed into 250 mils of normal saline. Now, here's a note that I want to make about this. Any dose calc question that you get, it does not matter what the medication is, okay? So when especially if you are just starting nursing school, like my friend, you don't know any of the medications, and that is totally fine. I remember being in nursing school, like starting nursing school and getting to these dose calc problems, and they'd be throwing out these medication names, and I'm like, I don't know what that is, so I can't answer the question. But no, it does not matter what the medication name is or what it says or whatever. Like, it could be, you could be giving 50 milligrams of apples. Like, it literally does not matter, my friend, okay? So whatever they throw out at you, don't let that trip you up. Whatever the medication name is, you don't have to know in order to answer the problem, okay? So you will be giving, let me delete that because that was kind of funny. You will be giving 50 milligrams of medication B mixed into 250 mils of normal saline. The order says to run it at a 100 milliliter per hour. So that's the rate we're gonna run it at, 100 milliliters per hour. How long will it take for the whole bag to infuse? In hours. Okay, so when we're walking through our 6-step process for dose calc, here's what this looks like. I'll write this off to the side, okay? The first thing is, what do we need? What do we need to end up with at the end? So what do we need? The next step, let me number these for you, make it a little easier. The next step is, what do we have? Like, what do we actually have, or what is ordered? Ordered? Am I spelling that right? Why do I feel like there's no ED? Let's just leave it as it is. Please don't comment below and tell me my spelling's terrible. 3 is conversions. Conversions. Conversion factors. So what conversions do we need to use in order to get from what we have to what we need to end up with at the end? So need is what units we need. Number 4 is to multiply, and divide. Step number 5, all right, is to actually round properly, like use our rounding rules correctly. Step number 6 is to check your work. Check your work. So this is our 6-step process here. What do we need to end up with? And that's the units. What do we need at the end? This is very, very important that you start out with what you need to end up with at the end, because oftentimes when you're doing a DosCalc problem, you might be solving for the wrong thing. We want to make sure that we are solving for the correct, like what the question is actually asking, because we don't want to do the whole problem, solve it all, and then find out that we solved for the wrong thing. And then what do we have, or what's ordered? And then 3 is conversions, and then multiply and divide, round and check, okay? So let's get started on doing that. And before I forget, I want to make sure that you know that I have a whole DosCalc cheat sheet for you that walks through all the conversion factors. So all the conversion factors that you'll need to know for your DosCalc exam, I actually have them listed out on a free cheat sheet for you. And I hope that'll be really, really helpful for you. So I will put the link down in the description for you to snag that after this video. Be sure to grab that because it is really, really nice, very handy to have, because those are the conversion factors that you have to know before going into your DosCalc exam. They don't give you those conversion factors during your exam. You have to actually have them memorized. You have to know them ahead of time. So that's very, very important. You want to be prepared for your exam and not be blindsided when you get there, right? So let's make sure you are prepared. So definitely grab that cheat sheet after you watch this video. So the first step is, what do we need? What do we need to end up with at the end? So I always like to write this on the right-hand side of the paper. So this is hours, is what it says. So we need hours. How many hours is it going to take the whole bag to infuse, okay? Now, what do we have, or what's the order? What does the order say? Now, here's a very interesting thing about this question, my friend. I remember getting tricked up on this a ton in nursing school, is that it says you will be giving 50 milligrams of medication B mixed in to 250 milliliters of normal saline. Okay, so how much are we giving? We are giving the 250 mils. All right, so because we're mixing in that 50 milligrams into the 250 mils, but we are actually infusing that 250 mils. Could you imagine like infusing like a powder? Not good, my friend, not good. So we are actually giving that 250 mils of normal saline, but it's mixed in with that 50 milligrams of the medication. So that 250 is actually what we're starting with, 250 mils, okay? 250 milliliters. I'll write that a little bit better. Okay. So 250 mils is what we are starting with. Now that could say like 100 milligrams that we're mixing into 250 mils. It does not matter. We are actually infusing that 250 milliliters. It's the volume of fluid that we are most concerned about here. So 250 mils of normal saline with the medication in it. So that's over 1. Okay, so we have what we need. That's hours. Now we have what's ordered. That's 250 milliliters, okay? So now somehow we need to get from milliliters to hours, okay? So now what does the question say? Does it give us any conversion factors? This is step number 3. Are there any conversions that we can use? How do we get from milliliters, from this milliliters right here, to hours right here? How do we do that? Well, here in the question, the order says to run it at 100 says to run it 100 milliliters per hour, okay? It says to run it at 100 milliliters per hour. So what we are going to do is use that as our conversion, because that is our conversion. So 100 milliliters per hour, okay? Now, here's a principle for dose calc equations like this, is that you have to make sure that the same unit is on the top and the bottom so that it can cancel itself out if you want it to cancel. So we want hours here at the end, but we don't want milliliters. So we need milliliters to go away somehow. We need it to cancel itself out. So milliliters right here is currently on the top. We need it to be here on the bottom. So we're gonna put milliliters here on the bottom, and that is 100 milliliters, okay, over 1 hour. Now milliliters here at the top cancels, here at the bottom cancels, and now we are just left with, boom, hours here. So 1 hour, we gotta straighten that out for you. 1 hour translates to exactly what we need over there at the end. So we canceled our milliliters out because if you have it on the top and you have it on the bottom, it magically disappears. It is math. That's math for you. They cancel each other out. So 250 milliliters over 1 hour over 100 milliliters. Okay, now next step is to multiply and divide. So we are going to multiply 250 times 1. We multiply across the top, then we multiply across the bottom, and we divide those two numbers. So 250 times 1 is 250. I don't know why I write the 5 first. Come on, Christina, get it together. All right, so 250 times 1, and then 1 times 100 is 100. So 250 divided by 100 is 2.5 hours. Beautiful. Okay, so that is the first few steps. Now, the next step, of course, is to round. But here, it's 2.5 hours. We're not going to round because it's just 2.5 hours. If we rounded to 3, that would be 3 hours. Like, we're not gonna round time. So this is written correctly, 2.5 hours. So the answer is 2.5 hours. Does that make sense? So those are the steps. Now, the last step is to check your work always. So when you are in clinical or in your dose calc exam, you always want to make sure that you are double checking your work. So we can do this again, and that's totally fine. You can run through it again and make sure that you just did all your math correct and everything. So that's a really, really important thing to do when you are taking a dose calc exam and when you're giving medications at clinical, to make sure that all of your math is correct. Cool. So now let's walk through the next problem. All right, so this one says your patient will receive a blood transfusion of 500 milliliters of red blood cells to run over 2 hours. Your IV tubing has a drip rate of 10 GTTS, so drops per milliliter. How many drops per minute will be infused? I love these questions. So we're gonna follow steps always, okay, because that's not going to fail us. We're going to follow the steps. What do we need to end up with at the end? And actually, I'm going to write this further to the side because this one is a doozy. What do we need to end up with at the end? We need drops, GTTS, per minutes. And drops, that GTTS is a Latin word. What is it? Guten, something. I'll figure that out and get back to you later. But it's something Latin. GTTS, it means drops. So drops per minute. Okay. So that is what we need. Now, what do we have? And we write this all the way on this side of the paper. What do we have? We write it on the left. Okay. So we have here, let me move this over, 500 milliliters of red blood cells. So 500 milliliters, and we're gonna put that, and it's gonna run over 2 hours. Okay, so we have 500 milliliters to run over 2 hours. That's what's ordered, okay? That's what we have, that's what's ordered. Now, our IV tubing here is 10 drops per mil. So let's just pause here and take a look at where our equations are. Here's what we need at the end. GTTS, drops per minute. Now here we have hours and milliliters right here. So we have milliliters over hours. Somehow we need to get from hours to minutes and milliliters to drops, okay? So that's the conversion we're looking for here. So we have one that the problem gives us. It's 10 drops per mil. So when we use that, let's try that one. And when we use it, we will see that we can get our drops. We want drops to be at the top because that's where it is here where we need it at the end. So drops 10 GTTS per 1 mil. And fancy that. Remember, like we said in the first problem we did, anything that we want to magically erase itself and cancel itself out has to go on the top and the bottom. If you see a unit that is on the top and on the bottom, they get canceled. So milliliters is canceled because it is both on the top and on the bottom, okay? So now what we have is drops per hours. We currently have drops right here, and we have hours right here. But that's not what we need. We need drops per minute, right? So we have drops, solid. We are good to go on that. But the problem still remains. We need minutes. So how do we get from minutes or hours to minutes? Well, we all know that there are 60 minutes in 1 hour. That's just something we all know, right? And so that is the conversion that you can use. There are 60 minutes in 1 hour. So we are gonna put hours here at the top because why are we putting it on the top? We're putting it on the top because it is on the bottom right here, bing, 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 it's on the bottom. So we need to put it here at the top so that they can cancel each other out, right? That's the magic of dimensional analysis, and I love it. So 1 hour is 60 minutes. So now hours can bing, bing, cross itself out. So now we are left with drops on the top, minutes on the bottom. It's exactly what we want. It's perfect, my friend. So now next step. So that was step number 3, is to do your conversions to make sure that you end up with what you need at the end, right? So now the next step is multiplying across the top and multiplying across the bottom and then dividing those two numbers. It's so awesome when you do it this way because it's so clear to see it and it's way easier than anything else that you could, any other formulas or anything you use for dose calc. I'm sure I'll talk about formulas in a future video because if you've been around for a while, you know how much I just do not like formulas. They will break as you go through nursing school and as the problems, the dose calc problems get more and more complicated, the formula methods will break you. They will break and they will leave you hanging, which is not a good thing. So this is why we do it this way. It's just so much easier and so much clearer to do. This is called dimensional analysis or railroad tracks. So 500, we're going to multiply across the top. 500 times 10 times 1 gives us what? 5,000. 1, 2, 3 zeros. Divided by 2 times 1 times 60. Okay, so 2 times 1 times 60 is 120. So 5,000, now we have 5,000 over 120. 5,000 divided by 120 is 41.6. 41.6 drops per minute. Now that we have multiplied across the top, multiplied across the bottom, and divided those two numbers, we got 41.6. Now this 41.6 GTTS per minute. You cannot, here's a principle to remember for dose calc and your dose calc exam, you cannot you're not going to look at the drip chamber and calculate 0.6 of a drop, okay? So we're always going to round drip rates to whole numbers, all right? So because 41.6 drops per minute, because it is above 5, remember our rounding rules, anything 5 and above gets rounded up. Anything 4 and below is rounded down. So 41.6 drops per minute equals 42 drops, GTTS per minute. And that, my friend, is our answer. 42 drops per minute. So that's the correct answer for this problem. All right, moving on up. Next problem. The patient will receive 1,200 milliliters of Ringer's lactated Ringer's solution to run over 10 hours. The IV tubing you'll use says macro drip at 10 drops per mil. How many drops per minute will be infused? Ooh, fancy. Okay, so this one is going to be another big one that we're going to have to walk through. So, of course, when you're following those 6 steps, we want to make sure that we are following the 6-step process exactly so that you can make sure that you don't get anything messed up or get it wrong. So we always want to start with what we need, right? At the end, what do we need to end up with? Now, this question is asking us drops per minute, okay? So GTTS, again, per minute. That's what we need to end up with at the end, all right? Now, what do we have? Or what's the order? All right, so the order that we have here is 1,200 mils to run over 10 hours. So 1,200 milliliters to run over 10 hours. Beautiful. So now kind of the same problem that we had in the previous question was we have milliliters, but we need to get to drops, and we have hours, but we need to get to minutes, right? So we need to use our conversions. Now, does this problem give us any conversions? And it does, but I wrote over it, of course. It used to say 10 drops per mil. Okay, so 10, this is our macro drip tubing, 10 drops per mil. So drops, where is drops gonna go? Is it gonna go on the top or is it gonna go on the bottom? I'll give you a minute to think about it. I wanna see if you get it right. And check yourself, okay? When we wanna make sure we're looking over here at what we need, drops per minute. So where does drops need to go? Does it need to go on the top? Or does it need to go on the bottom? Well, it needs to go on the top because it's here in the need at the top. All right, so 10 GTTS per 1 milliliter, which is wonderful because now milliliter crosses itself out. So now we have drops over hours, which is fabulous because drops is on top here, it's on top in the need, so that is exactly what we need. Now we need to figure out how to get from hours to minutes. And again, like we did in the previous problem, 1 hour is equal to 60 minutes. Easy peasy, 1 hour crosses out. Those hours cross out. Now we are just left with boom, 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 bingo, bango, bongo. GTTS over minutes, drops per minute. Okay, so now the next step, multiply across the top, multiply across the bottom. It's really that easy. Then divide those two numbers, okay? When we do that, we get 12. Oops, I don't know why that's erasing. I think I'm clicking a fancy little button on my pen. Oops, okay. Okay, Christina, don't click that button. It'll erase your stuff. 12,000. 1,200 times 10 is 12,000. And then 60 times 10 is 600. Okay, so now 12,000 divided by 600, when we divide those two numbers, we get 20 drops per minute. Oh, bummer, I can't see that. There you go, 20 drops per minute. Okay, now rounding rules, we don't have to round here because it's a whole number, which is beautiful. Like we talked about before with the drip chambers, you're not going to, you can't accurately calculate a percentage of a drop, or like a tenth of a drop, or like the second problem we did, like 0.6 of a drop. Doesn't work that way. So this is a whole number, which is beautiful. So our answer here is a beautiful 20 GTTS per minute. Ooh, Christina, that was sloppy, but that's okay. Now, a note that I want to make about this question here is that it says macro drip. Macro. Okay, macro drip. Now, macro drips for IV tubing, when you get a question that says they are using macro drip tubing, that could be either 10, 12, 15, or 20 GTTS, okay, per mil. So 10, 12, 15, or 20 drops per mil. That is for macro drip tubing. Now, here's the tricky part. Micro drip tubing is only 60 drops per mil. Only. Okay? So when you get a dose calc question, sometimes they will actually only tell you that they're using micro drip tubing. Sometimes they won't actually put the 60 drops per mil. Sometimes they will only say it's micro drip tubing, and they expect you to know that that means 60 drops per mil. Okay, so that's just something, it's a really important thing to note. That definitely happened when I was in nursing school, when I got to an exam, and man, I just remember thinking, oh, what was that? Like, I know this. What was that number? It's 60, okay? Got it? 60 drops per mil for a micro drip tubing, but macro drip can be 10, 12, 15, or 20. And when it is a macro drip tubing, just like this question says, they will specify. They will give you the number. They have to, because there's multiple options. But for a micro drip, it's only 60. Okay, so if this question said micro drip tubing, then we would have put in the 60 drops per mil. So I hope that makes sense. My friend, this was so fun. If this video was helpful for you, can you please let me know in the comments, because I actually really enjoy going through this on my computer here so that you can see it visually. I really hope that this was helpful for you. I do like talking through things in real time. I think that's why I like live videos so much. If you want me to bring the live show back, can you let me know too? Because I am going back and forth on that. I would really like to, because I just love interacting with you. I just like talking with you so much, just like seemingly in real life. So I hope this was helpful for you. Tell me in the comments if you want more dose calc practice problems like this, what types of dose calc practice problems you need, what you're studying, so that will just really help me to figure out what kinds of problems are most helpful for me to go over here that will help you the most, whether it be IVs or PO meds or, whatever. Let me know. I would love to do more videos on this, and I definitely do have a lot of dose calc videos coming for you very soon that I'm so excited about. Because like I said at the beginning of this video, we're gonna help you get prepped for the next term. So this is gonna be awesome, my friend. So let me know in the comments if you loved this video, and check out this video that I did. The video will be popping up here on the screen, that it walks through practice problems on PO meds and tablets. So if you need help with that, definitely check that video out. And as always, my friend, go become the nurse that God created only you to be. And I will see you over there in that next video.